Hey everyone, I'm going to continue on with the video that we just did talking about the fundamental theorem of algebra. We were talking about finding the roots when you're given a polynomial function, how you have to go through and figure out all the possible rational roots, and then using synthetic division to get to your answer. Excuse me. We also talked about that complex roots and irrational roots always come in conjugate pairs. And so, for example, and this goes back to the beginning of the other video, if you're given three rational roots or three rational zeros, then if you just subtract those terms or move those terms over to the other side of the equal sign, you end up with your factors. And these would be my three factors if these were my three roots. Let's talk about, though, when we have something other than rational roots or rational zeros. In this case, we have a complex zero, and we have, this should be square root 2 in there, we have an irrational zero. And when you look at this, you see only 3 zeros here, but remember, these come in conjugate pairs. So technically, I have 5 zeros here, which is going to make this a 5th degree polynomial. And here's why. I have x equals 1 plus I, but then I also have x equals 1 minus I, because they come as a conjugate pair. I have x equals square root 2, which means I also have x equals negative square root 2 as a 0 because they come as conjugate pairs. And then I also have x equals negative 3. And so if I follow the same rule that I did here, where I'm turning my zeros into factors simply by moving that term over to the other side of the equal sign, then here I would just be subtracting 1 plus I from both sides. And so what I would end up with is x minus 1 plus I is equal to 0. Here I would end up with x minus 1 minus I is equal to 0. Here I'd have x minus square root 2 is equal to 0. Here I have x plus square root 2 is equal to 0. And here I have x plus 3 is equal to 0. So these are my 5 factors. So here's 1, 2, 3, 4, and 5. And so if I wrote this out in factored form, just like I did here, I would end up with, I'm going to do a square bracket here, x minus 1 plus I, excuse me, times x minus 1 minus I, times x minus square root 2, times x plus square root 2, times x plus 3. And all of that equal to 0. So this is my factored form of my 5th degree polynomial function. Now, this is where it can get a little bit hairy, for lack of a better word, right? I'm going to focus on these two terms first, and I'm going to multiply them together. And all I'm going to do is FOIL. When I FOIL those together, right, and multiply my first two terms together, I get x squared. Multiply my outside terms, get negative x times 1 minus I. Multiply my inside terms, negative x times 1 plus I. Multiply my last two terms, 1 plus I times 1 minus I. Okay, so this is just I just multiplied together the parts in that blue box. So now I'm going to distribute. So I have x squared minus x plus xi minus x minus xi. And when I FOIL this out, I get 1 minus I plus I minus I squared. Your positive xi, negative xi are going to cancel out. Your negative I and your positive I are going to cancel out. Remember, I squared is -1, so this term becomes +1. So you end up with x squared minus x is minus 2x. 1 plus 1 is 2. That's that first part. Let's look at let's look at these two in this gray box here. Let's multiply these two together. So I have x minus square root 2, x plus square root 2. And when I multiply those together, I get x squared plus x square root 2 minus x square root 2 minus square root 2 times square root 2 would be square root 4, which is 2. Okay, my middle terms are going to cancel out here. So I end up with x squared plus 4. So I have x squared minus 2x plus 2 times x squared plus 4 times, I can't forget my other factor there, which was x plus 3. Okay, so I've got a lot going on here. I'm going to go on to a new page here. So here are my factors. X squared minus 2x plus 2 excuse me, times x squared. What I have here. Oops, that wasn't supposed to be plus 4. That was a mistake on my part, guys. Oops. That's minus 2. Sorry, I got a little ahead of myself there. Okay, these canceled each other out, and that should just be minus 2. That I don't know what I was thinking, but that should be x squared minus 2 there. Okay, so we've got x squared minus 2x plus 2 times x squared minus 2 times x plus 3. So again, I'm just going to go ahead and multiply these out. I'm going to look at my first two here and multiply them together, and then I'll multiply that by x plus 3. If I multiply those out, I end up with x squared minus 2x squared, sorry, x to the 4th. X squared times x squared gives me x to the 4th. X squared times negative 2 gives me negative 2x squared. Negative 2x times x squared gives me negative 2x to the 3rd. Negative 2x times negative 2 gives me negative 4x. 2 times x squared gives me 2x squared. 2 times negative 2 gives me negative 4. Okay, so that would give me x to the 4th minus 2x cubed plus 4x minus 4. This term and this term cancel each other out. And then I have to multiply that by x plus 3. So my final polynomial gives me x to the 5th. X to the 4th times x is x to the 5th. Plus 3x to the 4th. And now I'm going to do negative 2x cubed times both of these. So I get negative 2x to the 4th minus 6x cubed plus 4x squared plus 12x minus 4x minus 12. And let's see, these two I'll be able to combine together. These two I'll be able to combine together. That gives me x to the 5th plus x to the 4th minus 6x to the 3rd plus 4x squared plus 8x minus 12. And that, oops, is your final answer. Okay, that's a 3 there, by the way. 3. Now, there's a lot of stuff going on there, so let's just go back and sort of recap. Remember, first let's figure out the degree of our polynomial. Our complex roots and our irrational roots come in conjugate pairs. So if you only see one, that means there's actually two. 1 plus I and 1 minus I will be two of your zeros or roots. Square root 2 and negative square root 2 will be another pair of roots, and then negative 3 will be your fifth root. You have 5 roots, so it will be a 5th degree polynomial. Take each of those roots, or each of those zeros, subtract them, move them over to the side with x to get your factors. Once you have all of your factors, then you have to multiply them together. This is where it gets a little tedious and it's easy to make careless mistakes. So be very careful when you're doing this. Make sure that you are careful with your signs. Don't make careless mistakes. You see, even I made a careless mistake when I was doing this over here. Pardon me. So just be very careful with your signs. I multiplied my first two terms together to get a trinomial. I multiplied my second two terms together. I got a binomial. And then I had that one other binomial. And then I went through and multiplied those together. I multiplied the first two together and then took that product and multiplied it by my last factor. Combined all my like terms, wrote it in standard form, and that is my final answer. So there are lots of steps to it. Like I said, it's easy to make careless mistakes, so be very careful, but it is important that you go through each of those steps when you're doing these types of problems. Whether you have all real solutions, all rational solutions like this, or a combination of rational and irrational and complex like this. You're going through the same steps every single time. Some problems are just a little more involved than others, but the procedure is exactly the same. I will see you all in class tomorrow. We'll definitely review all this. Tomorrow there is going to be a quiz, so make sure you do the assignment tonight. Check the course page because you will only be doing the circle or the numbered problems, the numbers that I give you on the course page. You don't have to do all of the problems on the sheet. I will see you all in class tomorrow. Have a great day, everybody. Bye-bye.